quadratic application problems. This one's straight off the homework from page 81. It's a business situation where you're trying to determine what's the best price to price a calculator so that you sell as many as possible. That's called the optimal price. In this case, what you price a calculator affects how many you're going to sell. This makes sense if you think about cheap calculators versus expensive calculators. There is a price that's so cheap that they'll fly off the shelves, but you're not going to make very much money, and the goal of the business is to maximize profit. If, on the other hand, you charge too much for the calculator, very few people will buy it and you won't make much money either. So somewhere between those two possibilities is the best price, the optimal price, where you're going to sell enough calculators at a good price so that the company makes the most it can make based on the price of the calculator. And that's what this problem's all about. So here's the actual wording right off your homework. A company produces calculators and is studying the effect of changing the price. That's what we're going to look at. The theory behind this is that when you look at revenue, we're going to use the variable R for revenue. Revenue is the amount of money you take in before you pay any expenses at all. So it's just the income from selling calculators. Okay? The theory is that the revenue is a function of the market price. That just means the price at the stores. And we're going to use variable P for the prices for the calculator. So we're going to look at all the various prices you could charge, starting with 0, for the calculator, and how much revenue you would make based on that. And then there's a function for revenue. The function is revenue is equal to the price times this other little mysterious piece that we're going to investigate in a little bit. 3,000 minus 10 times the price. Okay, so that's the relationship between price and revenue. Okay, so now here are the 4 questions that they're going to ask you on the homework. If the revenue is equal to price times how many you sell, and that makes sense, right? The amount of money you take in, the revenue, is equal to what you charge for one calculator times the number of calculators that you sell. Okay, so that's a general breakdown of what the formula means. And if that's the case, then what does this 3,000 minus 10p part of the function represent? Remember, that was the mysterious part in the parentheses. Okay, well, let's look back at the formula again. So we've got P out in front. That's clearly the price, and that matches up nicely with price, right? Okay, times the next part's supposed to be the quantity. So 3,000 minus 10p is the quantity of calculators you sell depending on what price you charge. Okay, so the answer to that part is that 3,000 minus 10p is equal to the quantity of calculators you sell. All right. The other questions we're going to need to answer are, what is the significance of the value P equal 300? We'll check into that. And we need to find the optimal price. That's the goal of this whole problem, right? How do we decide what the optimal price is? So we're going to be looking at what price produces the best revenue, the biggest revenue. Sounds like a maximum, right? That's pretty typical for these problems. And finally, which range of prices provides at least $190,000 in revenue? This is a new kind of a question that we haven't seen before. A range of prices means that as you look at the graph of this function, it's going to be some sort of parabola like this. We're looking at which range of prices would produce, if you go up here, some standard that we don't want to go below. So we've got an ideal revenue, which is $190,000. And if you drew a horizontal line through 190,000 on that y-axis all the way across, we want to focus on what are all the points above that. And that's the range we're going to look for. And that's going to be some piece of the horizontal axis, those prices down here. And that's what we're going to study in the final question. Okay, let's look at these in more depth. All right, So we already figured out that if R equals P times that interesting expression in the parentheses, since R is revenue, P is price, and you're supposed to multiply price times quantity to get total revenue, then this is the quantity. Now let's look at the next question. What is the significance? That's like the meaning in a word problem. How does this affect the outcome? What does it mean in the problem? Of the value P equals 300. Well, I don't know. That's a price, $300. Let's see what happens when the price is $300. Okay, so remember revenue equals P times 3,000 minus 10P. Let's plug this value in. Okay, let's do some simplifying here. So this turns into 10 times 300 is 3,000. And now we have 3,000 minus 3,000 in the parentheses, which is 0, and 0 times 300 is 0. So that turns into revenue equals 0. Remember, revenue is the amount of money you take in. So 300 is important because, remember, it's a price. If the calculator is priced at $300, you make exactly $0 in revenue. So if we think back again at our theoretical graph here, some sort of parabola, this is that intercept where the revenue crashes to 0 when we charge $300 for the price. Okay, so that's one of our intercepts has been found for us already. That is the significance of this value. The significance is this price causes the revenue to be 0. Okay? Now we want to find the optimal price. Remember, we talked about optimal means best in some way, best for the business. The business is interested in revenue. We want to maximize revenue. So the optimal price is the price that occurs at the vertex of this graph, right? So the revenue is going to be the highest revenue. But revenue is not something we can control. Price is something we can control as a business, and that's why we're studying price instead of revenue. We are going to look at the maximum revenue, but only to find the corresponding price, because we can take an action about that. We can set the price at that optimal price, and then theoretically we will achieve the maximum revenue. So hopefully you see how the relationship between those two things and why it's important to focus on the price. So what we want to do is find the vertex, basically, or at least the price in the vertex, which is the first coordinate right there. Now there's two ways to get the vertex of any parabola. You can either complete the square from the function, which is up at the top, or you can find the two intercepts and see what's halfway between. One of the intercepts was already given to us. It's 300. The other one is not going to be very hard to find, so I think that's the faster route for this problem. To complete the square, you would need to distribute the p and then complete the square. That's also fine to do, and it'll put it in vertex form, but I think it'll take a little longer. Let me show you why. To find the intercepts, remember we set the dependent variable, in this case r, equal to 0. So we've got 0 equals p times 3,000 minus 10p. We already discovered the value that makes that expression equal to 0, and that's p equals 300. This one's super easy. P equals 0 makes that equal to 0, right? So those are our two intercepts, 0 and 300. I know the graph looked like that, but I hadn't done the math yet to prove it, so it's important to do the math. Okay, so if those are the prices where the revenue is 0, halfway between them is where the revenue is maximum. Halfway between 0 and 300 is 150. So the optimal price is $150. Now it doesn't ask for what the maximum revenue is, but let's go ahead and calculate it just to make sure we're good at that. All right? So remember, there's a revenue function. The revenue is a function of the price, so let's plug in 150. Okay, let's simplify this and see what we've got. All right, 10 times 150 is just 1,500. If we subtract that from 3,000, we get 1,500 out of it. And when we multiply that by 150, that's like 15 times 15, which is 225, with 3 zeros. So the maximum revenue that we can make is $225,000. and that's the other part of the vertex if you needed that. Okay, those are both in dollars. Let's look at that last question. Which range of prices provides at least $190,000 in revenue? Okay, so somewhere between $0 of revenue and $225,000 of revenue is $190,000 in revenue. Remember, it's somewhere on this axis. And if you imagine drawing a line across it at R equals 190,000 and seeing where it intercepts, these are the two minimum values. If you find the coordinates there, the price is the P coordinate at those 2 points, and everything between there is going to represent this part of the graph where all the revenue is at least 190,000. There's more than one way to find these values. One way would be to set the function equal to 190,000 to find the edges of the range. And then everything between there would be an acceptable answer. That looks like this. Okay, now because when you distribute the p, you're going to get a p squared term. This is a quadratic equation. So you would distribute the p and then get it set equal to 0. Move everything to one side, and then you would probably want to just plug it into the quadratic formula to solve it. You could also use completing the square to solve it. If it was factorable, you could factor it. I don't know if it is. But another option is to make a table of values, okay, and try to find out what are the prices. Now, you wouldn't want to do this by hand, but using a spreadsheet, you can do this very rapidly, and that's what I did. So I set up in a spreadsheet using this formula and a column of price values from 0 to $150. No, from 0 to $300. I actually had a spreadsheet calculate for me all the revenues for all of those points. So imagine plugging in everything from 0 to 300. You don't want to do that by hand, right? I did it by 5s and 10s and 100s to see how close I could get, and I'll show you the results. Here's the piece of the table that made the most sense to share. Starting at the price of $90 per calculator, the revenue was $189,000, so very close to the amount we want, but not quite enough. And then above that is above $190,000. I went by 10, so the beginning price is somewhere between $90 and $100. And I'm not going to drill down in any more detail. I'm going to leave that for you to figure out. So similarly, on the other end of the spectrum, above $200, well, once we get past the optimum, remember the optimum is $150 per calculator, right? So as soon as you get more expensive than that, notice that these values start decreasing. Okay, and that's fine. That's what they're going to do in a quadratic function. So they're going to drop, 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 and then right here is when it drops below 190,000, which is our cutoff. So somewhere between $200 and $210 is going to be that upper bound of what you can charge in order to have the desired revenue. Now, the distance from 200 is going to be the same as the distance from 100. So if you figure out what the price is at one end, it'll be pretty easy to figure out the price at the other. So you can use a table of values from 90 to 100 and plug in numbers if that method appeals to you. The other method that I showed you on the previous slide will also find these answers. If you set up this equation and solve it using the quadratic formula, you're also going to find the exact price between 90 and 100 and between 200 and 210 that is the cutoff. So those are your choices. I'd like you to finish that problem yourself, but this gives you a really good idea of where it's going to happen, where the answer is going to be. Okay, and that's the end of that problem. I've cut this video into 2 pieces so that we have 2 short videos instead of one super long one.